Hello dear students, today we are going to discuss the chapter D and F block elements, that is a LEP material. So Punjab School Education Board ਦਾ ਜੋ LEP material ਹੈ ਉਹਨੂੰ ਸੋਲਵ ਕਰਨ ਜਾ ਰਹੇ ਹਾਂ ਨੈਕਸਟ ਚੈਪਟਰ that is a D and F block element. ਸੋ ਜਿਹਦੇ ਵਿੱਚ ਕੀ ਹੈ ਸਾਡੇ ਕੋਲ 2 ਮਾਰਕਸ ਐਂਡ 5 ਮਾਰਕਸ ਸ਼ੇਅਰਿੰਗ ਕੁਐਸਚਨ ਆਣਗੇ. ਸੋ ਸਟਾਰਟ ਕਰਦੇ ਹਾਂ ਪਹਿਲੇ ਆਪਾਂ that is a 2 ਮਾਰਕਸ ਸ਼ੇਅਰਿੰਗ ਕੁਐਸਚਨ, next that is a 5 ਮਾਰਕਸ ਸ਼ੇਅਰਿੰਗ ਕੁਐਸਚਨ. ਸੋ ਸਟਾਰਟ ਕਰਦੇ ਹਾਂ ਆਪਾਂ ਪਹਿਲੇ. So these are the 2 marks sharing question. Next that is a 5 marks sharing question. So start करते हैं पहले. First that is what are the transition element. The transition element are the elements whose atom or ion are contain partially filled d orbitals that are called as a transition elements. Second and next write the general electronic configuration of transition element n-1 d 1 to 10 ns 1 to 2. Next write the general electronic configuration of F block element n-2 f 1 to 14 n-1 d 0 to 1 and ns2. ठीक है. Write any 3 coinage metals, that is a copper, silver and gold. These are the 3 transition metals, coinage metals. Next zinc, cadmium are normally not considered as a transition element. As we know, transition element are the elements in which the having the presence of unpaired d orbital electron. So in zinc, cadmium, mercury having the fully filled electronic configuration having no unpaired electron, no presence of vacant and half filled orbital. So since the zinc, cadmium, mercury have completely filled d orbital, so they are not regarded as a transition metals. Next as zirconium and hafnium show similar properties. So again both zirconium and hafnium belong to 4th group and they have similar electronic configuration and similar chemical properties. ठीक है. And this is all of due to the lanthanide contraction. Due to the lanthanide contraction, both the elements have similar atomic and ionic radii and similar properties. So as we know, in the atomic radii of zirconium is 160 picometer and hafnium 159 picometer. So similar, so they have the similar properties and that's why they have similar size and properties. Next a formula of manganite ion and dichromate ion. So in case of manganite ion, that is in manganite ion MnO4 2 negative and dichromate ion Cr2O7 2 negative ion. Next question, that is what is a mish metal. Mish metal, it is a alloy of cerium 50%, lanthanum 40%, iron 10% and traces of other elements like carbon, sulfur, calcium and aluminum. So these are the mish metals. Okay. Next, what are the characteristics of transition element? That is all the transition elements are typical metal. Transition elements show variable oxidation state and some of them that most common, that is oxidation state, that is a +2. Transition metal generally form colored compounds. Transition metal have large number of complex compound formation tendency. Transition metal and many their compounds show paramagnetic behavior. Transition metal and other elements show high melting and boiling point. So these are the main characteristics of transition elements. Next question, that is why is copper considered as a transition metal? So copper, that is according to definition, transition metal are those elements in which the incompletely filled d subshell. So in case of, for example, that is a copper having d10 4s1 and in case copper can be written as spin 3d10 4s1, copper 1 positive, that is a 3d10, copper 2 positive 3d9. So copper 2 positive, that is a 3d9 having one unpaired electron. Okay. And copper 2 positive has partially filled d orbital and it is a transition metal. So this is a transition metal due to presence of unpaired electron. Next question, that is a scandium water 63 positive is colorless and titanium water 63 positive is colored. So justify your answer. In case of scandium water 63 positive electronic configuration, that is a scandium 3 positive 3d0 and titanium 3 positive, that is a 3d1. So scandium has a no unpaired electron, no valence shell electron, so that is a colorless. And in case of titanium, that is a one unpaired electron, due to that that will show dd transition. So due to that that is a titanium water 63 positive is colored in nature. Next why manganese 2 positive compound are more stable than iron 2 positive compound toward oxidation state of +3 oxidation state. So since the electronic configuration of manganese 2 positive, that is a 3d5, which is a half filled and hence a stable electronic configuration, therefore the third ionization energy is very high and third electron cannot lost easily. In case of iron 2 positive ion, the electronic configuration is 3d6, hence it can lose one electron easily to give the stable electronic configuration 3d5. So that's why the manganese 2 positive compound are stable due to the half filled electronic configuration, and iron 2 positive compound are toward the oxidation state plus 3 are stable due to the gain of stability. Next, that is why are lanthanides are called as inner transition metals. Lanthanides lie between lanthanum and hafnium. So both lanthanum and hafnium are d block elements or transition element, as lanthanide have a transition metal of d block on both sides and they are called as a inner transition element. So f block elements are lie between d f block below the d block elements, so that's why these are also called as a inner transition elements we कहते हैं ਆਪਾਂ ਇਹਨਾਂ ਨੂੰ, ठीक है, and lanthanide are also called as a inner transition. Next are the transition metal have a high melting and boiling point. So again transition metal, they have a transition metal are known because they have the presence of unpaired electron, that's why they show high melting and boiling point and dd transition and color property. So due to presence of unpaired electron, the electron in the atom transition atom element in the general have a strong interatomic interaction and hence stronger bonding between the atoms. So this stronger bonding between the atoms are very strong, as a result melting and boiling points and hence enthalpy of atomization become high in nature. Okay, so this is the next answer. Next, why transition metals show variable oxidation states. So transition metal, the variable oxidation state of a transition metal are due to the availability of both n-1d and ns electron for the bond formation. So as the energy of a penultimate d orbital and ultimate s orbital are nearly same, so the sum of total of ns and n-1d unpaired electrons determine the highest oxidation state shown by transition elements. So that's why they show the variable oxidation states. Next time, why manganese 2 positive compound are more stable than iron 2 positive toward the oxidation state plus 3. So again आप already पहले ये वाला क्वेश्चन भी किया था, ठीक है. So next question है, in the transition metal and their compounds many act as good catalysts. So transition metal act as good catalyst because due to presence of unpaired electron, the transition metal have possessed the capacity and emit so transition metal possess an capacity of absorb and emit a large range of energies. By doing so, transition metal takes the required energy for the activation available. So that's why they show good catalyst. In transition metal, they show variable oxidation state. They may form intermediate compound with the one of the another, and these intermediates produce a new path between the lower activation energy, and transition metal also provide a suitable large surface area for the with free valencies that a reactant can be easily absorbed. And for example, vanadium pentoxide that is used as a catalyst in the manufacture of sulfuric acid by the contact process, and in the finely divided iron that is a manufacture used of ammonia, manufacturing of ammonia use करते हैं in the Haber process. So this is the answer. Next, the transition metal have a high melting and boiling point already done. Why zinc, cadmium, mercury are soft and high melting points, so have low melting points. So the reason is that these zinc, cadmium, mercury belong to group of 12 long form of periodic table with electronic configuration n-1 d10 ns2. These elements are soft and have low melting point and high volatile. This is due to the fully filled d subshell in the penultimate, and such dd overlapping are not possible. Next, that is a preparation of chromate ore. So in the first step, that is a conversion of a chromite ore into the sodium chromate, that is a chromite ore react with the sodium carbonate in the presence of oxygen, that will form a sodium chromate. In the second step, a sodium chromate by in the acidic condition, that will changes into sodium dichromate, and sodium dichromate with the KCl react, that will form a potassium dichromate. So similarly, that is a potassium permanganate the preparation and the pyrolusite or magnesium oxide MnO2 in the presence of potassium hydroxide and oxidation in the presence of heating, that will give potassium manganate. Second, that is oxidation of potassium manganate to potassium permanganate, K2MnO4 that will give a KMnO4, so plus a Mn2. So this is the preparation. Next, that is a important question, define lengthened contraction cause and consequences. So this type of question asked again and again. So first of all, that is a lengthened contraction. That is the steady decrease in atomic and ionic radii of a lengthened element with increasing the atomic number is called as a lengthened contraction. And in the lengthened series, as we move from one element to another, the nuclear charge increases by 1 unit and 1 electron is added. The new electrons are added to the same inner 4f subshell. However, the 4f electron shield each other from the nuclear charge and quite poorly because of very diffuse shape of f orbital and the nuclear charge. However, the increase by 1 at each step, hence the increase atomic number, the nuclear charge, the effective nuclear charge experienced by each 4f electron also increases. As a result, whole of 4f electron shall contract at each successive element, though the decrease is very small. The result in gradual decrease in lengthened with the increase in atomic number. The sum of successive reductions give the total lengthened contraction. So जिस तरह ग्राफ ਦੇ ਵਿੱਚ ਵੀ ਕੀ ਹੈ ਕਿ lengthened element ਜਿਸ ਤਰ੍ਹਾਂ atomic and ionic radii increase ਹੋ ਰਿਹਾ ਤੇ ਉਹਦੇ ਨਾਲ atomic ਤੇ ionic radii decrease ਹੋ ਰਿਹਾ with the increase in atomic number ਦੇ ਨਾਲ. So next, that is the consequences of lengthened contraction, that will show similarity in the properties, that is zirconium, hafnium, nibinium, thallium, and similarly among that is elements show lengthened contraction and basicity difference, also the consequences of lengthened contraction. Again, colored compounds also already done, variable oxidation state already done question, zinc, cadmium, mercury have low melting point, but already done. Next, that is a explain why copper 1 positive ion is not stable in aqueous state. So this is copper 1 positive is not stable in, but copper 2 positive are stable. This is due to the hydration. Enthalpy change of a hydration of copper 2 positive ion is much higher as compared to the copper 1 positive. Therefore, it compensates for the second ionization energy of copper, and hence copper 1 compound is unstable in aqueous solution and undergo disproportion reaction to copper 2 positive, that will give copper 2 positive plus copper. So transition metal have a tendency to form complex compound due to the presence of n-1 d orbital, which can accept one or more electron. And second, that is a high charge density on transition elements or transition metal cations. For example, CO cobalt water 4 2 positive and Cu-NH3 4 2 positive, having the high ionic charge and large smaller size of metal ion. Next, again transition metal already done, lengthened contraction already done. So last which, that is the difference between lengthened and actinides. So the difference is, first, that is oxidation state in lengthened element, that will show +3 oxidation state, and it can few show +2 +4. In actinide, that is it show +3 oxidation state, and a higher oxidation state +4 5 6 7 can be show. Binding energy binding energy of 4f are higher, 5f are lower. Shielding effect of 4f electron have greater shielding effect, and 4f electron have poor shielding effect. Tendency to form complex, lengthened have tendency to form complex is less, actinide has a tendency to form complex is greater. Lengthened compound are less basic, actinide compound are more basic. They lengthened that do not form oxo ions and actinide form oxo ion. ਰੇਡੀਓ ਐਕਟੀਵਿਟੀ ਪ੍ਰੋਮਥੀਅਮ ਨੂੰ ਛੱਡ ਕੇ ਬਾਕੀ ਸਾਰੇ ਕੀ ਹੈ ਨੋਨ ਰੇਡੀਓ ਐਕਟਿਵ ਹੈ and all actinides that are radioactive color most of these ions are colorless and most of actinide ions are colored, for example U3 positive. Paramagnetic, they are paramagnetic and their magnetic properties can be easily explained, and these are also paramagnetic but their magnetic property can be easily explained. So ये सीगे साढ़े most important question जोड़े D and F block element दे chapter दे. So all the best to all the students and get good marks. Thank you.